So what we're going to look at, and I want to send this out to you guys just so we can go over just a few of the key principles. A lot of the stuff's going to sound very, very familiar. A lot of the stuff you may have done in the past, but I kind of wanted to just give a little bit of a brief overview for you. So we kind of go over these things, so we'd be prepared for Monday when we start looking at actually going ahead and mapping out a process and taking those lean steps and those lean improvement steps. So if we look at it, when we look at lean, we really got 6 challenges. So we've got the aspect of having to re-engineer the process, and really a big part of that is what we're going to be doing next week in terms of mapping it out, looking for things like storm clouds, things like that. So you'll learn what those terms are as we go through. Also looking at how we effectively use technology, not just the information technology, how we effectively use our resources. Also how we use the knowledge and skills in that actual source of management there. And then how we look to develop effective teams and how we look at the coordination across multiple different pathways. That's usually where a lot of the challenges come from. And then really, the ultimate thing is taking all of that and then making it actually possible. So going to the implementation aspect. Anyone can plan out something, it's going ahead and having it within the implementation aspect. That is often the toughest part. So really good when we look at dimensions of quality, and we're going to keep a few things in mind when we're actually going ahead and mapping out these processes. Is we're going to be looking at, of course, safety. We're going to be looking at the effectiveness, because that's one of the things we want to look at. Also looking at the patient-centeredness, always making sure that the patient's within focus. Maybe a little tough with some things, but pretty much with anything within healthcare, we can always relate it back to that patient. And then we'll look at the equity. We're also going to look at the efficiency of it. There is a difference between effectiveness as well as efficient. You can have an efficient process that is not effective. You can have an effective process that is not efficient. We want them both combined together. And then also timeliness. Time is money. We want to make sure that we're taking the fewest steps possible within a process, not having any redundancies, things like that. And you'll see as we start to map things out, you'll begin to think, wow, we're doing that 2 or 3 times. Or we're actually having to loop this back to the start, and then we're going from there. So it will be a good exercise. So looking at where lean does originate, a lot of you may know this, but lean came from Toyota, basically. They've been using it for quite some time. They've used both lean and Six Sigmas as well as TPS, which is the actual Toyota production system, which is what lean is encompassed within. And it's just really now starting to move into healthcare, probably in the last decade. And, it looks at the approach in terms of how we look to streamline things, how we reduce waste, how we reduce redundancies, and then taking a new approach to actually looking at problems. Because, with manufacturing, steps are important. Having to reduce waste and things like that can make a process a lot more efficient. Same thing within healthcare. So we take those same actual principles and apply them in the healthcare realm. So if you look at this, it does require some focus on the whole system as well as the processes. So it's not just looking at the problem, it's looking at the entire system, because things lead up to one another. The problem just doesn't all of a sudden appear all the time. It can. But when you look at it as a whole, you can see the entire process, you can see the exchange, you can see handoffs, things like that. And you can better get a sense of where your redundancies are, really where your root cause is. So it's really a relentless focus of drilling down on what we're doing, how we're looking at things, and also applying the PDSA aspect of, yes, we look to plan and map out. We go ahead and do what we're going to plan, and then we look to study it. And we look to see if it's changing or anything like that. And if there's any issues, then we look to fix those. You can call those, some rapid cycle changes, or we like to call them a Kaizen event. And then you act on those. You go ahead and fix it. So it's a continuous process, and the PDSA is within there. And as we move through things, we'll get involved with that as well too. So this is kind of the lean improvement cycle. So we look to define the value. We're going to be looking at that next week and defining, okay, what's our actual goal here? What are we looking to go ahead and lay forth? And then we're looking at the ID to value stream, where we're mapping it out, where we're looking at it. And then we're going to look at what that process is and see where the issues are, and then make a value flow, basically look to redesign a process that we feel, based upon inputs and based upon what we see, is the best flow and is more consistent and standardized. And then we also look and see, is that focusing on the customer, both the internal as well as the external? And then, once we get those aspects, we look to pursue perfection. And that's where we look to study and act. We look to study what we did. Is it working? Is it having the effect we want? If it doesn't, then we look to revisit it and we look to address that. There's nothing wrong with a lean project, having to go back to it and maybe tweak a piece. That's expected. That's what we want to do. You're not always going to get it right the first time, and there's nothing wrong with that. It's getting the pieces right and having the right approach to it that puts you down the right track. Now, we look at why lean is relevant. So it's really not just a manufacturing tactic. It really looks at the organization, looks at all the processes, and looks at leaning things out. It looks at looking at things within processes or sets or action as they should be in how they create value. If we're doing something that doesn't create a value, then should we be doing that step? Is that a step we need to do? Sometimes within healthcare you may have that just based upon regulatory aspects. But for the most part, you'll learn as you begin to process things out that, we're doing a step we really shouldn't have to. That step doesn't need to happen if you do this. So those are the things we're looking at, and that helps to streamline things and also helps to standardize things as well too. That goes back to those manufacturing principles of, why do we want to have this part go here and have this done to it, and if it's done, down the line again. These are those things we have to look at. We're looking at those redundancies because that's where your waste is. That's where you lose a standardization. That's where you increase your risk of having issues within your process. And, you're simply doing more work and not actually getting any benefit from it. Now, you look at the economies of flow. And, we have the mass volume thinking, which is kind of where most states are, where most hospitals are, where most businesses are. They think in a actual different scale and concept, where they're more focused on the problem versus the process. The information is only need to know versus things like that, and it's a little bit more siloed. So you have a lot of these spots of centralization of key information, but you can't get to it when you need it to help improve a process. With the lean thinking, it really begins a shift of thinking. It looks to the right size, making sure that what we have is scaled to fit us. Also, we look at the focuses on the actual processes and how we look to glue things together, how we look to make things a lot more standardized, to make them with less steps, versus just saying, okay, here's a task we need to do, let's do it. Oftentimes you get a lot of variation from that. Yes, you get it done, but how much work is expended in doing that if you have a standardized process? You really are always doing that same aspect no matter who's in that role. And you can also find when there's issues, what the root cause is a lot easier. If you have 10 or 12 different ways of doing something and there's some issues with that process, it makes it hard to find the root cause. Also looks at everyone has their skills and they're expected to use them. So there's accountability within the system of we have a defined process. We have this is what should happen, A, B, C, D. So when B doesn't happen, it's the responsibility of that person. So there's some accountability within there. Also, we look at information in terms of the visual sense. The human brain looks at information in a very visual way. We all actually process that way. Some maybe more than others, some maybe less, things like that. But for the most part, when you map out processes, when you look at them, it's easier to see where those holes and issues are versus having, say, a procedure in front of you with step-by-step directions. When you map it out and you show those flows and you show each step, it makes it a lot easier to look at the problem from the big picture sense, as well as within little parts of it, which we call like the microsystems, and really look to tackle the issue. And also it's about root cause. So if we look at it, the better quality is actually cheaper. So, the other side is, the increased quality is going to cost more. You have to buy, some better materials, we have to spend more time, all this stuff. Well, really, especially within healthcare, the higher quality you have, the cheaper your delivery is. Because to get to quality, you have this little hurdle. You get to having, you're doing good, you're doing well, you have quality. But when you get to go into the high quality, you move into the benchmark of moving into standardization, looking at how you affect things, how you standardize processes, how you lean things out. And that helps you jump that little hump or hurdle to get to the higher quality end. And it actually reduces costs because the standardization reduces variation, and variations cost money, and then the variations create issues, they cost time, all these things. And we look at managing by a variety. So we look to skills to rapidly change from one item to another. Basically, we look at multiple skill sets around the table to solve a problem. We also, if we need to look at things, we're going to pull in those who need to be. We're not going to have one, manager or director think, I can fix this because I'm at that level. We don't know all the pieces. And it's good to have those multiple skills because then you have the expertise to quickly adapt and address things and to get that instant feedback. So sources of variation within the clinical system. There's quite a few different types of variations. And, about 80% of those are under our control. We actually control the variation for the most part. Some stuff we can't control, but for the most part, it's all on our shoulders. Staff, we got the processes, patients, we got the resources, and we have information. So these are all things that have some pieces in there that we can control, of course. Some you can't by looking at the list. But for the most part, the actual variation we see within our system is because of us. So when we start to think based upon process and actually reducing that actual variation, we're taking more and more control of our actual processes to where we're at the point where pretty much everything that we can control is in control. And that makes it better to adapt to those outside things that you can't control, whether it be the regulatory changes or things like that. But you have what you need within control. If you don't have that, then you're not only having to adapt to the changes on the outside environment or whatever, but also having to compensate within your own issues too that you have within the process because you're not controlling all the variation within your system. This results in systemic issues. Okay, so when you don't control that actual variation, or at least look to limit it within your own processes, the areas that you can control, you begin to see systemic issues where you look at, say, like, the poor scheduling or appointment resources, or really complex pathways where you have delays built in, absence of process ownership and control where you have some processes that everyone's like, what, it's not mine, I don't know whose that is, I thought this was this person's, well, this person was taking care of this type thing. Also, you have few defined processes, so you don't have standard working. We're doing something, we don't have a standardized process for it. And also you'll get the unqualified capacity and demand. So you have those aspects where you can't look to quantify those. You can't have to adapt to your capacity. You're not able to work within your means, or you can't flex to handle more workload. So if we look at value stream thinking, we're stopping looking at the aggregate activities. So this is one thing we're going to look at next week when we start the mapping process. We're looking at the actual specific activities and how they interact with each other. That's what we're looking at. And we look at those within a process map. So a process map answers questions such as, what is waste in the process? So, we're looking at, okay, what's redundancy? What are we doing that we don't have to do? The waste aspect. Where are any blockages to the flow? So where can there be some blockages in terms of maybe there's a wait time, or maybe there's delay here, maybe you have to wait for someone to come down, or maybe there's only one person that knows that role, so if they're out, we can't do that process. And also, how long does each process step take? We look at even mapping out, okay, so if we do this and that, there may be a 10-minute time period. If we do this and that, there may be a 5-minute time period. So looking at how we can speed up things and also knowing where those delays are and how we can handle them, because that's part of the patient experience too. Eventually, when we look at more and more of the lean concepts, say like 5S and stuff, we'll even map down the steps. How many steps does some person take to get the nursing supplies on any given day? Because if you, design where your storage is for supplies better, you can actually give those nursing staff more time with patients. More time with patients equals better scores. So even just mapping out how many steps you take to get, say, like, the gauze or whatever nursing supplies you're using can actually reduce and help improve the quality of care that you're doing. So not to mention save on, cost of shoes and stuff like that. But so we also look at how many handovers are there. So how many different stops are there? How many does, say, it goes from one department to another or one role to another? We look at those handovers because those handovers have some areas for risk in terms of having the experience breakdown or having some issues. So we want to make sure we look at those and also say, okay, is that handoff necessary? Is that a necessary handoff? Maybe the other person is actually trained in how to do that, but they're still handing it off to someone else who's doing that thing that they are actually trained into. So we look at those aspects and we map it out. So we look and map out the process in terms of analysis. This is one thing that I'll be doing with you guys. So we'll be going through what the process is. It's nothing really all that magical, but it's simply drawing on a whiteboard. Here's where we're at. Here's the steps. And you see with this one, it's nice and neat. It has one little start point. We may have 5 or 6 different start points that lead into one thing, and there may be offshoots of another. When we see this and we see the spider web, we want to try to reduce those lanes. We want to try to reduce those different routes that can create some variation. So we'll see these as we map it out. We'll call them storm clouds, or we'll call them Kaizen bursts. Is kind of the term I like to use from my training, but whatever we want to call them, and see if we can address those. Also, we look at the 2 elements of every job. So we look at the value adding versus the non-value adding. We're going to be looking at these as we map things out. And this is where there's an effort where it's going to add things to the process. It's not going to take away, or it's not going to be a redundancy. It's not going to be a waste. Because if we're doing things that really don't add up to the end result, why are we doing them? Can we streamline them? Can we take those out? Those are the things we want to do, because you'll be surprised how much redundancy and how much waste, or even how many different types of avenues we have to do a singular job, when we can really standardize down to one route, and we can waste our staff members' times of having to train different ways, or having to have some different resources for each. So, and the types of waste, we look at the 7 types of waste within the actual TPS program. So we have transport, we have inventory, motion, waiting, we have the overprocessing, we have the overproduction, and then we have defects. The actual last one there is more of a higher level concept, so I won't hit that one. But even like the transport, we have patient transport. We move patients here and there. It's just like it would be within manufacturing of shipping goods. We're moving the patient. We're moving our good that we're going to provide a service to in a different way. And even, having to go up and down the elevator 2-3 times, or having to go here and there. Having staff members take a different route to a department each time. What's the most consistent route? What's the shortest route? What saves the most time type thing? Also looking at inventory, supplies and things like that. We look at motion. These are the things in terms of our actual process. How are things moving through it? And in this case, the patient or cars being parked, whatever. We also look at waiting times. This is a key thing too. We look at delays, both delays caused by the process or delays caused by handoffs, even delays caused by whoever we're moving through the process. And then we look at the overprocessing and overproduction. This is basically the redundancies. Where are our redundancies? Where are our waste? Where are we losing time? Where we have someone doing something on multiple times? That's what we're looking for. And then the defects, the ones that just simply don't work. It's never worked, but we've had some band-aids, and it works say like half the time, so that's good enough type thing. Looking at those defects and saying, okay, how can we fix this? What should be the process for? What's the ideal state? And standardization. This is an important challenge in healthcare. We look at standardization, and it's tough to do, especially you look at the multiple types of disciplines and the multiple people that are in the roles, as well as multiple departments, to provide a singular set of healthcare for, say, like a person's, say, like just an outpatient visit. Just think of the potential people and the potential departments that could be involved in that singular service. So it can be tough to standardize, and it is a challenge, but it's one that we need to look to do, because with the standardization, it again reduces your error, it reduces your effort, and you begin to be able to find some better root causes of things when you do have issues, and you can better adapt, which is going to be highly necessary in the next few years within healthcare. And it does require multiple people around the table. It requires all the groups involved within that process around the table. Very, very different concept of problem solving than a lot of places look at. You may have a few of the higher ups and say, this is what we're going to do. Whereas with the lean, you have those within the middle down looking at a process, trying to look at it. Those who actually have their hands on it to look to fix it, because they're the best ones to ask. They're the ones doing the process. They have the insight for it. And also requires a clear way in which it's shared, and how we share the information, making that available, making sure the processes are trained the staff and things like that. And then also having agreements on what we're doing, agreeing on those changes, and having all the groups around the board has the ownership, it has the accountability, and then also looking to track the performance, looking at that study and act aspect where we say, okay, this is what we're going ahead and implement. Then at this point, we have to study it. We have to see if it's working. If it's not working, what's not working in it? Let's fix that piece. Let's go ahead and adjust. And then let's study some more. That's a continuous cycle. You're never going to get it right the first time. If you think you are, then you have some misconceptions there. But, if we get a process set out and we map out what the ideal state is, guaranteed we're going to run into some hiccups in that first few times we go ahead and pilot it. And we're going to have to think on our feet. We're going to have to quickly act. Say, okay, here's the information from this. Here's this process. Okay, this is going to work to fix this, and then go ahead and implement that. When you have a standardized set process and everyone knows their role, that's easier to do. When it's disjointed, that's tough to do. Very, very tough to do fast. So lean tools, we're going to look at the value stream mapping, which is what we're going to do. We're going to map out the process. We're going to look at things, and I'm going to walk you through that. And there'll be some more terms and stuff thrown at you. But for the most part, think about what your process is. Think about your role in it. Because we're going to go through and touch all of those. So kind of think of in your mind those steps. And those are the things we're going to discuss. And trust me, you're going to think there's maybe 5 steps in your role or 2 or 3 steps. And then you're going to slowly build. We're going to start to map this out. And you're going to say, okay, what you thought took 10 steps now takes 25 steps. Happens all the time. Or even sometimes you may think it takes more and it takes less. That often doesn't happen, but it can. And then we're going to look at the PDSA cycle in terms of how we implement things, how we're going to study it, how we're going to determine if it's efficient, and then how we're going to meet if we do have any issues once we roll, whatever it may be out. And then we're going to understand the demand capacities as well as the variation. When you look at a process, you not only want to get the ideal state, but you want to talk about what possible scenarios could happen, what type of variation can we see, how do we handle that, how do we address it, and also what's the capacity of it, what's our demand going to be. So we're going to look at those things that, yes, here's the process, but these things, if this happens and this is the consequence of, say, whatever going wrong, what's our capacity to handle it? What's that variation? What's our response to that? So we're going to think and try to have a crystal ball a little bit so we can plan for what the unexpected may be. And oftentimes that's a spot and miss within the regular planning methods. Then, the root cause analysis. So if we do hit a storm cloud and we do hit, say, a blockage or, say, like a barrier, we're not going to ask who or what. We're going to look at the whys. Why is that? Why is that a problem? Okay, so why is that a problem? Why can't we fix that? Why do we address it? How do we address it? How are we going to address that type thing? The hows and whys. Those are what we look at. We don't do the what and who's. Those are blame aspects. The how and whys are going to be solution oriented. That's what we want to do if we look at these storm clouds and as we address them. The 6S visual management, this is not going to be one that we'll cover. Again, this is kind of a generic PowerPoint that I've had here and there and used. So we're not going to cover that. It's a little bit higher level, as well as the Glenday Sieve, as well as the rapid improvement events. I refer to these as Kaizen bursts, whatever you want to do to, potato. These are basically where, we ID within our process a small issue that may not be a part of the whole in terms of process, but we say, okay, you know what, here's an issue, it's not related to our process, we can quickly fix it. And you go and quickly fix it. Usually these things are things and problems that can be solved in less than 3 days with very little team involvement. Less than 3 days with a team smaller than 3 people or say like 3 people or less. So very, very small teams, very, very quick acting. We may use these when we look at the study and act cycle within PDSA, where we may have an issue when whatever actual process we decide on goes out, and there is an issue. There usually is an issue, and how we go ahead and address it with some small teams, and we do, and that's the beauty of Lean. You don't need to meet and have a meeting again to fix something. We've already done that process mapping. We all understand it. We look at it, say, okay, this is why. This is the how we're going to fix it. Let's go ahead and revise that process and boom, get it in place. So it's very, very quick acting. It's very, very easy to triage, and you get that new actual result in place, and you go back again studying and acting on it. So it's always a continuous cycle. The slowest part is the process mapping, and then finding all the storm clouds and addressing those. So that's the slowest part. Once we get the process that we want mapped out, then we implement it. The fun part begins in terms of monitoring things and having that actual quick DACing stuff. The mapping process is fun too, but for me, it's always about once we get the process out there, seeing if it's going to work. And if it's not, if we have a piece here and there, having to think on your feet and work with the team to kind of adapt and address. That's kind of where it becomes fun, at least for me. So then we look at the effective flow. It's part of the entire system. So we may have microsystems within each one of these pathways, or say within each one of these results where they may go to lab or radiology and this and that. And within those systems, their flow may work well, but it's in those handoffs. In those handoffs, we want to make sure there isn't variation as well too, because that's what the patient's going to notice. For that patient, it's a seamless process. For us, from our perspective, it's not. They went to lab, they went to radiology, they went to provider, they went here, they went there. For us, it's a separate process, but for that patient, it's one seamless experience. And they're going to notice those actual issues a lot more than what we will within our own silos. And that's why it's important to things to even look at, okay, if we're sending them here on the first floor, and then we're sending them up here on the second floor to do this, and then once they do this, they have to go down to the basement. Well, you know what? What's a better route to do that? So we're looking at those things in a different perspective. We're looking at it and making it a seamless process with as little sources of variation as we can, which is why they call it lean. We're making the process as lean as we can, reducing the number of steps, reducing the number of pathways, and trying to reduce the number of handoffs that limits variation. And when you limit variation, you control the process a heck of a lot more. And if there's something going wrong, you can monitor it and you can adapt to that process a lot easier. Plus, if things change and the environment changes, be it with the regulatory, whatever it may be, you can adapt that process a lot better than having a complex, webby mess of processes to get one thing done. So that's kind of how we're going to look at things, and we're going to map things out. And you'll see, once we map things out, we'll probably have a big, process with multiple pathways and things like that. And we'll have to take that and look to see where those redundancies are, where we can reduce them, and where we can make the ideal state. And we may have 5 or 6 different storm clouds that we're going to have to address and ask those, why is this happening questions. Okay, how can we fix it type questions. So the mapping out process may take a little bit longer, and it depends upon what the complexity of, say, that issue is. This one may be complex or it may not be. So we'll have to see. And with this, and sorry for the printer going on there in the background, I wanted to record this. I actually tried recording it last night, and it just didn't work. So here I am, but I wanted to get this stuff out to you guys here first off so that you actually had it. So I do apologize for the printer going off in the background. I'm only doing this in one take, so it is what it is. But when we look at this, this is an example of just a basic type of patient flow, and this is just a hypothetical example where we have a process that actually has 4 different inputs. So it starts 4 different ways. And again, doing this in one take does result in a little bit of some interference there. So we will bring it up here. So look at this again. Like I said, things can start in multiple pathways, and those are the things we may have with the scenario that we're going to look at. We may have multiple different sources that feed into the singular process, or maybe 5 or 6 different sources that feed into 2 processes. So we'll have to look at that, and that's part of what we're going to do with mapping it out. And again, just wanted to kind of cover some of the basic concepts to kind of get a little bit of prep, because we're hitting the ground running on this with the first Lean project. Normally actual full Lean class of learning the concepts and all the stuff here and there usually takes anywhere from 2 to 3 days. Not full days, usually 2 to 3, 4 to 5 hour sessions to get the basic lean principles and that. So we're kind of doing a little bit of a crash course here, but I wanted to prepare you guys a little bit so things weren't so foreign. Again, it's probably a lot of stuff that you already know, but we combine it in one big package. And as we begin to map out the processes, you'll see it's kind of a different approach to having people around the table to help us solve what may be an issue or even design a process. So that's all I have. Again, thanks for your time. I didn't want to assign any homework to you there. So again, I have the professor background, so I'm not going to have you do a discussion or anything on this, but I just wanted to give you guys some basic information for it, so we prepared as we start Monday on that lean project. So I look forward to it, and let me know if you guys have any questions in the meantime.